Hi everyone, this is Dr. Stecky again. Thank you for joining us again. This time I'm going to troubleshoot problem 650. This is the problem where you are having to figure out what warehouses to open and then how many units from each warehouse to ship to which regions. So you have two sets of decision variables. The student who did this basic model has absolutely nailed that structure. So you can see they've got their binary decision variables here, and they have their non-binary decision variables, which is the number of items to switch from what warehouse to what region in these sections, and they've done a fantastic job getting that down. Their basic structure is really, really good. There are a few minor issues that are keeping them from being able to complete the model. First of all, if New York then LA, they have that as an equals. So let's think through this logically. So this one here, this C11 is New York, and so then LA is this one here, so C12. So what they're saying is that these have to be equal, so that if you open New York, then you open LA. But the converse then is true if you have it equal. If you open LA, then you have to open New York. And that's actually not what this is saying. This is just saying if you open New York, then you have to open LA. That means that you can open LA without opening New York. So in that case, LA could be 1, and New York could be 0, and that would be okay. So instead of equal, what you want is that it has to be, that New York has to be less than or equal to LA. So that means that if New York is 1 and open, then LA has to be, okay, it's telling me that's not a formula. Thank you very much. I know that's not a formula. Let's do our, let's do our parentheses so that it knows it's not a formula. There we go. And the other thing we could do is we could do it like she did, so greater than or equal. All right. So again, that means that mathematically, if New York is 0, then LA could still be 1, and I need to put that back so it still references the cell. If this cell is 0, then LA could still be 1, and that would be okay. All right, so that fixes that constraint. Okay, this section right here, just at a glance, probably causes an issue with linearity. For shipped out, you don't want to refer back to the cell. So what she's referring to is C11 times F17. Yeah, so the binary constraint times the total. You don't want to do that for the part that's shipped out. I'm pretty sure that's causing an issue with linearity. We could run a linearity report and verify. And I always recommend you do that if you're having any trouble figuring out where your linearity issues are. But if we just take this out and make it equal to F15, so again, mathematically it's the same thing, but it reduces the issues with linearity, it should eliminate the issues with linearity there. Okay, so now the upper bound, that's where you needed to make sure that you had, you weren't having issues with linearity. Okay, and I see what she, let's see. Actually, maybe put the constraint over here. Okay, so that sum is good. Let me go into solver. I want to see where she put this. Is it F17 or B32? Where she actually put that constraint in. She only need one of them. Okay, yeah, so I think we can actually take this one out if the F17 constraints are in, and they are. Okay, yeah, so these constraints are duplicated, and it's going to be, I'm sure that that's got to be causing issues. So I'm going to go ahead and take that one out. Just close solver back out. All right, so this capacity, instead of doing 10,000 all the way down, we know that if you open any given warehouse, it's $10,000 or 10,000 units. So we can just do a capacity constraint for the warehouse, put that as 10,000. Okay, and then instead of just putting this at a fixed 10,000, we can refer to cell B8, which is where I put the 10,000 constraint, make that an absolute value so we can copy and paste it down, and then multiply that by your binary constraints. Okay. And then as we copy and paste that down, now we are constrained to not ship items from warehouses that don't exist. And so you actually then don't need this little section right here, I don't think. So now let's look at the costs. There's some product. Okay, that looks good. And let's look at the fixed costs then. It should be the decision variables times the fixed cost of opening the warehouse. Very good. So that looks good. All right. Now let's see if we rerun solver if we get a correct model. All right. So the model is now running, but that's not the correct answer yet. So let's see if we can go back and figure out what's going on here. All right. So let's go over to our answer check, and let's put in the numbers that we were supposed to from answer check. So we should be opening, according to answer check, we should open New York and Atlanta. And again, remember, answer check is not giving you the optimal solution. It's just giving you a quick and easy way to check and see if your formulas are in correctly. All right, so then we're going to ship 500 here, 500 here, and 500 from Atlanta to region 3. Okay. All right, so that these two formulas are correct, or look correct. We've got 500 going to all of them, obviously far less than required. All right, so let's look at our costs and see if those are calculating correctly. Yep, that actually does look right. So fixed cost here. Yeah, okay. So this is a 1 instead of a 2. So let's change that and see if that fixes it and has it running correctly. If it doesn't, our formulas look correct. We need to go start looking at our constraints. See what's wrong there. Yeah, 579 is still too high. So I'm thinking we've got a constraint that's probably wrong somewhere and throwing everything off. So let's go into solver. Sometimes the easiest thing to do is actually just take out all the constraints and then put them back in. So that's what I'm going to do this time. I'll talk about them as I'm putting them in so we can make sure that they are going in correctly. All right. Now, this looks a little bit different than your answer check in that I did the capacity constraint over here because that's sort of how she had it set up. So let's put that in first. So the amount shipped from each warehouse has to be less than or equal to the capacity for the warehouse. So that's constraint 1. Next constraint. Total shipped has to be greater than or equal to the total demanded. All right. Now, have to, actually I think this constraint was supposed to be that you could only open a maximum of 2 warehouses. So I'm going to flip that sign because it should be less than or equal to, not greater than or equal to. Okay. All right. If New York, then LA. So New York has to be less than or equal to LA. Okay. Yeah, we actually didn't. Okay, I see. She had the at most 2 warehouses here. We actually didn't need that. We have to open at least 1 warehouse. We can't ship anything out. So, all right. Now let's look at the Atlanta or LA constraint and see if that's accurate. So either Atlanta or LA. Yeah, and so this is actually not a greater than or equal. So I'm going to go ahead and cancel out of this. I'm going to close out of this. And let's redo this constraint. So either Atlanta or LA. This should actually be a sum. So either Atlanta or LA. should be a sum of the binary variables for Atlanta and LA. Okay, and then that needs to be constrained to be, I believe it's greater than or equal to 1, right? Because it's either Atlanta or LA, yes, so then it's got to be greater than or equal to, and it's got to be 1, not 0. So let's go ahead and put that constraint back in solver. That one might have been the issue, so I didn't catch that one last time. So has to be greater than or equal to 1. Okay. That should be all the constraints. Let's go ahead and solve. So now we've got 423. So actually, I see what we did. Not good here. I forgot my binary constraint. So let's go ahead and put that back in. And I suspect that we're close enough at this point that we'll get it at that point, but we'll see. There we go. These have to be binary. Okay. Now let's solve again. Yeah, now we've got it. So we're getting the correct answer, 481,000. All right. And our ship 2 is correct. Yep. So this model is now correct. Again, I believe the issue that held us up before was this either Atlanta or LA constraint. This has to be a sum. So again, I hope you found this helpful. I'm also going to do a brief video on problem 663. I hope that you find that, hope that one is helpful as well. So have a great evening, and if there's anything I can do for you, let me know.